Okay, so let's start on the panning then. First thing I want to do though is actually to change the way we do our drag and drop slightly, just to make it a little bit easier actually and less code. So the idea is basically rather than figuring out where the mouse is and then translating the world coordinates to the local SVG coordinates and then moving the shape or whatever it is to the same coordinates, we'll basically just take the mouse delta. So at every interval, as we move every millisecond or whatever it is, as we move the mouse, we will then move the thing that we've clicked on the corresponding distance as well. Should be a lot easier, less code. The first thing I think we need then to do is just to define what it is that we're dragging, because it's at the moment we're either dragging the grid itself, which will be our kind of panning, or we're dragging a shape inside. So dragging the grid or dragging the shape. So let's just do an enumeration then, just so we can use that to make it obvious what it is to differentiate. So let's call it drag operation types. Okay, and then we could say let's do one of those types will be a shape. Sorry, let's go to choose 0, and then the grid equals 1. Okay, so that should be okay for that. And then actually, if we want to use this inside the template, we need to expose it as well. So let's just do that underneath the view child there, and we can declare it as public so that we can use it inside the template. And let me just call it drag operation types, small d, and then we have to say type of drag operation types equals drag operation types. I know it's a bit of a mouthful, a little bit verbose, but this is how we get the enumerations to work inside the template. So yeah, deal with it. Okay, what we then also want to do is just change the pointed down method as well. So if I look in the code here, and here's the pointer down. So actually what I'm going to do is I'm just going to comment this out completely, just to move it out the way, and I'm going to kind of start again. So the way we're going to do it is when you click on something, you're going to send the mouse event. We're going to send a reference to what it is that you clicked on into the class level variable, so we can keep track of what it is that's currently selected, and we're also going to see what sort of drag operation type we're doing, so whether it's a shape or a grid. So we're going to say then it's called pointer down, which is what it was called before, and this time we're going to change these arguments slightly. So we're going to take the just call it event, which is going to be our mouse event. We're going to take a reference to the thing we clicked on. Let's call it selected element. Okay, lovely, which is going to be an SVG element. And then we can take the drag operation types, which is going to be drag operation types. Perfect. And okay, that should do us. And then actually let's just console log these out. Just to be sure we're getting all the right stuff. So take event, so copy paste this, bash, selected element, and drag operation types, drag operation, sorry, actually that should probably be a type, really, shouldn't it, to be honest, because it's the type, not the types. Okay, and then let's also change this call then inside the template itself. So we've got a call here pointed down, and let's just change that one. So it's going to be pointed down equals our new method, and we want the dollar event, which should be the first argument. The selected element, so the thing we're passing through will be a reference to the grid itself, and then the drag operation type should be drag operation types dot, and this one would be grid because we're right at the top level here. Grid, thank you. Not very much IntelliSense. Drag operation types, just check that's what we called it. Drag operation types and type grid. Okay, cool. And then let's do the same then for the guy at the bottom here, the actual shape itself. Actually, let's just copy all of that, put it on a new line. Here we go. And the thing we need to change there is a reference to this actual element itself. So let's just call this rect1, not very imaginative, but it'll do. And then the drag operation type is going to be shape, I believe. Let's just check that. Drag operation type shape. Okay. So that should do it in theory. Cool. And then if we just click on this, let's just see. Yeah, we get our console output. Selected element. Oh, we're getting two. Drag operation type 0 and drag operation type 1. Okay, so the event must be bubbling up. So I think we need to probably in our handling function there, we need to do, I guess, put a event.stop propagation on that. Event.stop propagation. That should stop it bubbling up from the whatever we clicked on, whether it's a square or something, up into the grid. So if we click on that now, yeah, we just get the one drag operation, and if we click on the grid, we still get the grid. Okay, perfect. So let's create 3 class level variables. So it's the selected element. I think we've already got that one. Yes. Let's take the last mouse event. Are we using that one? No, let's do that. So basically, every time the event fires and we're dragging the mouse across the screen, we'll check how far it's moved since the last time we got that event. And then we can calculate how far we need to move the shape or the grid, whatever we're dragging. So let's call last mouse event. Let's create that up there, and then let's do also, yeah, the drag operation types. And I really can't be bothered to type that out again. It's kind of long. Drag operation type, and we could probably be good citizens and give these a type. That is an SVG element. Last mouse event is gonna be a mouse event, and drag operation type is obviously the one that we've got here. Drag operation types. Okay, so those 3 guys there. I don't know why there's still SVG tests. We can then store that when we click or when we do our mouse down. We can then store those. So this dot selected element equals the selected element. We want that. We want the last mouse event. Last mouse event equals our event. Okay, cool. And then we need the one more for the drag operation type. So this dot drag operation type equals drag operation type. Okay, so when we click on something, we know what it is we clicked on, where the mouse is, and what sort of operation we're performing. Now let's start looking at the actual drag itself. So what I'm going to do actually is I'm going to comment out this old pointer move as well. Let me just copy the signature. Let me just comment all of that out actually. We're going to start again up here in our new improved smaller version. Pointer move. So that's going to stay the same. It's just going to have a single event which gets passed in. That was going to be these guys, pointer move. We'll probably need to implement that on there. So point and move, then we can say basically we want to know if we've got something selected basically. So have we clicked on something? Are we dragging the grid? Are we dragging the square? So we can. So first thing to do then to check is if we've got a selected element. Okay, so that's the basic first check. If that one fails, then there's no point in doing anything else. And then let's just do, I'm going to put a switch in here actually because I think we're just looking at the moment to see whether it's a shape or the grid, but it feels like it could be possibly extendable to other things possibly, so I'm going to leave it a bit more open by putting it a switch rather than a million if and else if statements. And then we're going to switch on the drag operation type, and in there we're going to do case this dot drag operation type. Oh, sorry. So it's case. So drag operation types dot. Let's do shape first, and we're going to do something in there. Wash, and then let's do the same also then for the grid. Drag operation types dot grid, and then let's just quickly console log those out here, just so we can see that this is actually working. So drag operation type. Oops. Let's just say point and move, and then let's just say shape here, and then grid here. Okay. Okie dokie. And then let's just see if we can get some console output from this. So if I start moving the grid around, you can see we've got point and move grid, so that's good. If I start moving the shape around, point and move shape. Okay, lovely. So that's good so far. So next thing that we need to do is we need to start looking at the distance the mouse has moved since the last time this function got called from us moving the mouse across the screen. So we're going to need like a delta x and a delta y for these things. So let's put those in here. And let's say let mouse delta x equals, so the event dot client x, so this is where we are now, minus this dot last mouse event dot client x. So the first time this gets called, obviously there's, we haven't this last mouse event, this will have been set only in the pointer down. So this is where we set it here. So it will be initialized there, and then the first time we actually start moving the mouse, this offset, or sorry, this delta will be calculated here, and then for every time we drag the mouse another increment further, it'll be calculated further in here. So let's do mouse delta y, mouse delta y equals event dot client y, and then whoosh, minus this dot last mouse event dot client y. Okay, so that should give us the distance vertically and horizontally that the mouse has moved since the last time, and with that then we can use that to calculate. Let's just do it for the shape first. We'll just move the shape the same distance up or down or left or right as the distance the mouse has moved. So let's say current x, current x equals so this dot selected element, whatever it was we clicked on, dot get attribute, and it's attribute namespace here because we're getting one of the SVG elements, and we can't just use get attribute, we have to use get attribute namespace because it's in namespaced by SVG rather than the default HTML. So null, and then x, which is going to be give us the x of the selected element. In this case, we've only got the square here, so give us the x of that. Where is it horizontally? And actually, we want it to be. This is going to give us a string, but adding two strings together doesn't give very good maths. So let's do a parse float on this guy too, and then that will make that a number. And then we can do exactly the same then. Copy that line out for the vertical position. So let current y equals this dot selected element get attribute, and we want y. So where is this thing? Currently situated? Then what we're going to do is we're going to move it. So current x plus equals, so where it is now, move it over by the distance that we moved the mouse. And then we can say the same as well for current y plus equals mouse delta y. Move it by the distance the mouse has moved. So we've got the number now, and then let's just write it back into the element. So this dot selected element dot set attribute, and it's set attribute namespace ns. Don't forget these, it's super annoying and completely unapparent and just doesn't work with not much indication of why it doesn't work. We want to set the x, and we want to set it to the current x, and this wants a string. It's a bit fussy, but anyway, it is what it is. So we need to change that back to a string again. We needed to change it to a float to do the mathematical calculation. Now we need to put it back in again, set the value, so it needs to be a string. So okay, like so, and then this dot selected element dot set attribute namespace, and then we want to do the y, so null dish y, and then we want to say that is going to be the current y, to string, of course. Okay, so let's try that. May or may not work. Oh, okay. Well, that was quite a big jump there. Let's just figure out what went wrong with that. That's kind of interesting. Moved the mouse a little bit, but it was like looks like the scale is that's the value's been multiplied too much somewhere. So what was that? Okay, so actually what we're doing is we're not setting this every time that we get a pointer move event. We're not actually setting the place where the last mouse event was. So we're always calculating the distance between where the mouse has moved and where it actually originally started from, not where it was last. So we need to say, actually, at the end of this, this dot last mouse event equals event, and that should give us the correct delta, I think. Let's try it. Yeah, okay. It's a bit more reasonable. Okay, so let's do the same now. We've done it for the drag operation for the shape. So let's also do the same for the grid. So the grid, here we go back into the view box land again. So let's do exactly what we did last time. We'll get the view box attribute, which was, remember, it was like the string of 4 numbers like that. So what we want to do is we want to split them up into 4 things, and then we want them to be numeric. So let's just say view box x, view box y, view box width, and view box height. Okay, so helping us out a little bit with some IntelliSense. Thank you, Visual Studio. And then we want to do this dot SVG grid dot native element dot get attribute. This is just a get attribute because it's actually still inside the HTML namespace. We're not actually inside the SVG yet. We're just declaring it, and it's view box with a capital B. Won't make that mistake again. And then we want to split it. Split, and we want to split it by space. So that should give us the 4 numbers, and we want them actually be numbers. So let's do a map on that. And string, and we want to say pass. Yeah, we want to pass floats of s. Okay, so that should give us 4 floats into these variables. Thank you very much. Now we want to do exactly the same as we did with the shape. So we can say the viewbox x. So viewbox x plus equals. No, actually, it's going to be minus equals the mouse delta x, and it's going to be viewbox y minus equals mouse delta y. And this seems kind of weird, and I did have to have a think about it first, but actually when we're moving the view box around, we are effectively, if we go back to my lovely diagram again, you can picture it that we're on a scale, and let me just make this a bit bigger actually. Let's take the stroke off. Let's give it a fill of red, no stroke. Thank you very much, Photoshop. Let's say we're on a scale like this. Okay, so we've got these two guys, and let's say that's our X and Y axis on these. Maybe I can just bump these up a little bit. They're a little bit on the small size. Problem with selecting these things when they're so small. Can we move that up from 20? Oh Jesus. The strokes magically come back. We don't want a stroke. We wanted just a red fill. You going to do that? No, it's not. It's going to be a pain in the butt. Okay, fine. We didn't actually want the arrowheads. Can we take that off here? No. So it's going to turn into a Photoshop madness. And let's just do the same for the other one here. Can we select it? Yeah, we can. Let's just give it a bit red stroke. Fine. So that's going to be our X, and this one's going to be our Y. Y axis going up, the X axis going across there. So there are two ways that you can think about this when you're looking at the view box. You can either think that you're moving the view box sideways, or you could think that the view box is actually, the content is staying still and you're actually moving the rest of the content across in the opposite direction. And that's kind of the way that the SVG works. It's a little bit strange, but it's if you're moving positively, panning positively, it's the same effect as the viewbox window moving negatively in the opposite direction, kind of like relativity. So that's why we get the negative there for the pan here. So we've got those two. Now that we've done those, let's just put them back again. So we can then say the scaled view box. scaled view box equals, it's going to be our new view box X, our view box Y. The view box width is still the same. We've not done anything with that. We've just translated it. And the view box height. Okay, pardon me. Let's map those back. Map. And this time we wanted to, let's round them off so they're not too crazy with millions of decimal places. To fixed, and let's just make them 2. Okay, lovely. And then let's join them back. Join them back again so that they're a string with spaces in it. And then we can set it on the SVG grid. So this dot SVG grid dot native elements dot set attribute, and it's set attribute, not attribute ns, because we're still in the HTML namespace. We want to set it on view box, and we want to set the scale view box. Okay, I hope that kind of made sense. So let's just see if we can drag that. Okay, that's good. Good stuff. But one thing you'll notice actually is, as we move the mouse, the speed at which the content pans is different from the speed at which the mouse is moving. So we need to factor that in. So what we need to do is we need to keep track of the amount that we zoomed in. So how far we zoomed in and out, which is basically the kind of the ratio between the mouse speed in the HTML window and the speed at which the content will move underneath. We need to preserve that relationship. So the easiest way to do that is really just to create a class level variable to keep track of that. And I'm going to call that current view box. View box to SVG ratio, and I'm going to set it to 1 just because we're starting off at the same proportions. Oh, sorry, sorry. The view box is the same size as the actual SVG when we start off. So let's set it to 1, and then. Actually, when we do our zooming, we want to be able to keep track of that. So that's going to be in the sorry, here we are, the mouse wheel event. So let's get when we've got the scaled view box width. Let's just do that down at the bottom here. We're going to set it. We can set it to. So this dot current view box to SVG ratio. So we know how far we've scaled it because we got that here, which was the width minus the zoom scale. So we can say the scaled view box width. And then we want to do that as a proportion to the entire SVG. So we can just do that on the s.svg grid.native element, and then we want to get the entire width of that. So the client is going to be the client width. So that's not the view box width, that's the width inside the HTML window. So one thing to notice, if you were using a responsive design and this thing was changing, then you'd need to handle this inside a window resize event. But for the sake of this tutorial, I'm not going to go too crazy with this. So this should give us our ratio now anyway, and then we can apply this. Just make sure it still works. Good. And and then we can apply this now to the pointer move event. So in our going down, our mouse delta x, we can multiply that by the scaling factor. Oops, sorry, it's this. So it will move it if we've zoomed in, it will move it a fraction of the distance. And we need to do the same then also in the calculation here. So that should possibly work. Works fine, not zoomed in. Let's zoom right in, and that seems to work. And let's zoom right out, and yeah, that works also. And let's try it on the grid. Grid works fine. Okay, super. I'm happy with that. Okay, so what's next with this then? I think one of the problems that I see is that when you drag this over the shape, for example, to the edge of the viewport, the edge of the SVG, it would be nice if the thing kept on moving and scrolled over to the right if I drag it to the right edge, or scroll down to the bottom if I dragged it down to the bottom. I think that'd be really useful behavior. So let's go ahead and implement something like that. And to do that, we need to know kind of where the mouse is in relation to the edge of our SVG. So if it's kind of reached the very edge there by the by the outer bounds, I think maybe we'll create like a little border, maybe like 10 pixels or something like that. We'll call it a gutter. And if our mouse has moved into the gutter, we can assume that we're kind of dragging over all the way over to the right or all the way down to the bottom, and we want to continue dragging, so we don't have to go back and keep doing this kind of thing, because that's just annoying. Let's create 4 variables basically to keep track of the top, bottom, left and right, so we can figure out where our gutter should be. So let's scroll back up to the top here, and just below here, let's create 4 variables. Let's do SVG, let's do top, SVG left, SVG right, and SVG bottom. Okay, cool. So that should keep track of those. Now we just need to assign those. So the way that Angular works is as the page is initialized, there are a few things that happen, but one of them is this view child assignment, which is basically how Angular gets a reference to elements in the DOM itself. And that happens at a stage in the Angular lifecycle, which is exposed by a method inside Angular called afterViewInit. So what we're going to do is we're going to assign these variables once the page is loaded and Angular is loaded into a sufficient state that we can actually get a reference to the SVG grid. Okay, so it sounded like a bit of a mouthful. The way that we need to do this then is to actually implement the Angular lifecycle hook. So implements is called afterViewInit, and we need to import that from the Angular core. Immediately it'll give us an error because we haven't implemented it. We said we haven't. So we need to implement it's called ng afterViewInit, and it takes no parameters. Oops, let's try that again. And there we go. Okay, so that's made it happy now. So to get these 4 parameters, then we can use our get screen CTM, which gave us the offset of the top and the left of the grid, and then we can work out the right and the bottom basically by adding the width and the height. So let's get the screen CTM first of all. Screen CTM equals, and it was this dot SVG, which SVG grid dot native element, and then we wanted to get screen not screen ATM, get screen CTM, get screen CTM. Okay, and that should give us access to those properties. Let's just console that out actually, just to make sure that it's actually doing what it says on the tin. Okay, fine, and then save that, and it should just load up. There we go, screen CTM, fine, super. Now if you remember from the previous video, screen CTM has got 6 properties. Let me just expand that. A, B, C, D, E and F. Hugely self-explanatory. The ones we want are E and F. So E is the distance to the very left side of the browser window. F is the distance from the top of the browser window. Okay, so we can use those two, and then we can get the width and the height, and we can add those on, which will give us the other 2. So let's do that. So this dot SVG left equals this dot screen. Screen CTM dot E. Okay, it's the left. This dot SVG top equals screen CTM dot F. And then we need to do the right. This dot SVG right equals left plus this dot SVG grid dot native element dot client width. Yes. And then we want this dot SVG bottom equals SVG top plus this dot, sorry, can't be bothered to type that again, and it's going to be the client heights. Okay, so that should give us those 4. And then we can start working things out from there. Okay, so assuming that these guys are working, actually, I know it's boring and you've seen me typing it a lot, but I would like to make sure that these are actually sensible values. Left is 28, which is right, so that's the same value as the CTME, and CTMF should be the same value for SVG top. That's correct. We know it's 500 pixels wide, so that's correct. So it's 500 plus 28 and 500 plus 95 from the top. Okay, those are good. So I'm happy with those, and we don't need to really console those out. I think we're happy that bit is working. So now let's go ahead, and this time when our pointer moves, which is down here on the pointer move event, let's up here, let's create our gutter size, and let's say gutter equals, let's say it's somewhere around 10 pixels, somewhere around 10 pixels around the kind of the perimeter of the shape. The one thing to notice, like, our mouse events won't work once we're out of the SVG, because we're actually only handling them on this SVG element. So we don't get any information once the mouse has moved outside of it. So we kind of need to still be inside, just kind of at the edge really, to figure out whether we need to continue this or implement this continuous drag. So let's do 10 anyway first, and let's see how that works. Then what we want to do is say if so the event dot client x, so this is the x position of the mouse, and if it's greater than so if it's greater than the right side of the screen minus 10 pixels, which will just be the kind of little bit, just a little bit over to the left of the right, if that makes any sense. This dot SVG right minus the gutter. Okay, and then let's just console log that out and see if we can get some sort of response from that. So let's say right gutter, and we don't really need another value there, so let's save that. Okay, let's try that now. So moving it over to the right, shape move, shape move, shape move, shape move, shape move. There we go, we've hit our right gutter. Actually, we're also getting some selection here as well. So I think that's on the bottom of the, it's on the mouse move, pointer move. I think we need to say at the bottom of this, we should say the, we also need the event.stop propagation actually, because it's turning into a selection event. Oop, stop propagation. That should stop those numbers from being selected when we moved over to the edge. No, I think we probably then also need event.prevent defaults. Probably need that as well. So let's try that. So hopefully that should stop that. Okay, that's good. What we actually really want to happen is, once we've hit that gutter, we want the drag event to be fired as if we were moving the mouse. So we kind of need to fake that mouse move event. So to do that, we can use a recursive function call. We'll use the JavaScript set interval, which will basically call itself iteratively every X milliseconds. But I think to do that first, what we're going to need to do is refactor out some of this code just to make it slightly easier to call. Okay, so let's create two functions then, one which will be basically for shape, dragging shape, and one which will be for dragging a grid. Okay, let's just pop these down here. Actually, the arguments are going to be pretty much like so. Let's do drag shape, and let's do one for drag grid. Okay, like so. We're going to want to take the selected element, obviously, selected element, which is going to be our SVG element. We're going to want to take the mouse delta x, which is going to be a number. Oops, excuse me, a number. And we're going to want to take the mouse delta y, which is going to be a number as well. Okay, and for the grid, actually, well, there's only one grid, so we don't really need a selected element for that, to be honest. We just need the mouse delta x and the mouse delta y. So let's code those in, and mouse delta y, which is going to be a number. Okay, so those are what those two functions are going to look like. And then let's just pull the guts out of these guys. That can come down here and plonk that in there like so. Let's just get the indentation reasonable, and let's do the same then with the grid. Let's move that down there and then pop that in there. And then we just need to make sure that we're actually calling these, and I think we can probably get rid of those console logs now, not needed. We don't want this selected element, we just want selected element since we're passing it in as a parameter. It's just used in those places. Fine, perfect. And then we just need to be able to call these then. So it's going to be this dot drag shape, and we're going to want to pass in this dot selected element, the mouse delta x and the mouse delta y. Perfect, so that should work for that. And then, sorry, that was doing this the wrong way around. That was for the grid, and we actually wanted it to be for the shape. So for the grid, we want to drag grid, and we only want the 2 parameters for that, like so. Okay, so let's check that actually still works. We haven't broken anything. We drag it around, yes, that's fine. Drag it around, yes. Zoom, drag it around. Okay, perfect. Okay, so then the next thing we want to do is let's build the actual interval timer that will recursively call these recursively call the methods to move the shape and the grid. What we want to do is if we're in the gutter, actually we want to just handle that exclusively. We don't also want to be calling the other shapes. Sorry, we don't want to be calling the drag and drop for the grid and the shape itself, because we're going to be taking care of that ourselves. So let's just do that out there, and then this is going to be called anyway. Perfect. So let's just make that a little bit tidier. Okay, super cool. And then let's start implementing this out a little bit. So let's also do, I think we're going to want, we're only going to really be doing this with the shapes when we drag them. I think the grid, you can kind of drag it as you want, or you can zoom it in and out. Let's just do it with the shapes for now, but we'll put a switch in so that if you want to extend this afterwards, or maybe I'll extend it afterwards, that's fine. So let's do it for the shapes first, so when you drag the shape into the gutter, it'll keep on panning for us. So this dot, what do we call it, drag operation type. So and then let's just say case drag operation types dot shape. Okay, cool. Let's just put a break in there. That should sort us. Okay, so at this point we're going to want this recursive code to be called. So we can do a set interval, and this will execute a function every X number of milliseconds. So we can put our function in here, and then we can say, for example, every I don't know, let's start off with every 1000 milliseconds we want this code to run, which will move our pan, our grid, and move the block for us. And we can then call this dot drag shape, and we want, with the selected element, which is, we know it's guaranteed to be the shape, since we've only got one, since we've already filtered out the operation type, it must be the shape. And then we want to pass in, let's say we want it to, every 1 second, every 1000 milliseconds, we want it to move by X, 20 pixels in the X direction. and let's not do Y for now. Let's just try and get it working for that. And then what we want to do is the same thing for the grid, but if you remember, the grid has to go in the opposite direction because of the way that the view box works. So this dot drag grid, we only got one grid, so we didn't need to say what it was. -20 and 0. So that when we drag the block to the right, it should move everything over to the right. So let's see if that possibly works. So going super slowly, moving over. There we go. So that's moved over. And if I move the mouse out, might be kind of nice the further you move the mouse out of it, it kind of moved a bit more quicker. But anyway, so that's fine. So that kind of works. It's a bit of an error there, but we'll work on that. So what we also need to do, I think, if we move this over, it's not quite perfect. I think we need a bigger gutter. I think it's still moving actually. So once something else happens, I think this is actually still moving itself. You can see it's still trying to go. So we need to cancel this thing basically when anything else happens. So to do that, we use the clear interval. So it's JavaScript keyword. But to clear an interval, we first need to know what the interval is. So let's assign a class level variable to keep track of that. We'll put it up here, and we will call it pointer. Let's go pointer move interval. Okay, that'd be fine. And then we can assign that actually when we set it down here. So this dot pointer move interval equals set interval. Okay, cool. That's good. And then when we do the pointer up, which was our kind of mouse drop release event down here, we can just say if this dot what do we call it? Sorry, pointer move interval. So if we got one of these and it's been set, then we will use the clear interval and passing it in the reference to the interval time object. So when we move the mouse up, that should stop that thing from moving. So let's just try that. Move it over. Okay, and then we move the mouse up. Okay, that's good. So it's stopped again. Okay, it's not perfect. It's still complaining about some things. Selected element get attribute. Okay, no problem. We'll figure that out in a minute. So let's put that back. And we need to do it actually for the other three cases as well. For the when we've reached the bottom, the left and the top. So let's implement those two. Okay, so we got the right. Let's do the bottom now. So else if, and we're gonna say it's going to be the client y events dot client y is going to be greater than this dot SVG bottom. It's going to be oops. And it's going to be minus the gutter. So if we move it down to the bottom, okay, so that's going to be that condition. Actually, I think we need to be clearing the intervals actually, because if you move the mouse over to the right and then you moved it down to the bottom, you don't want all these functions to be firing, and then you moved it outside over to the left and then the top. It's going to be these interset interval functions are still going to be firing away in the background, and that's going to be make some crazy madness. So let's just grab this actually, and let's put it at the moment. Let's make sure that we put it let's put it up here actually. get rid of these for now. So just make sure that it's the first statement here in each of these. I'm just going to copy and paste this switch. We may do something with this later, but for now let's just grab that. We want shape this time, so we're moving the shape, selected element. This time we are moving it in the Y direction, so 0x and 20y, and then the grid will also be in the opposite direction, so that'll be 0x component and then minus 20. And let's take this magic 20 and let's put up here let step size, let's just call it step equal 20. That'll be fine. Okay, and then we just use that everywhere, so we can change it fairly easily if we want to change that size. So 20 there, minus 20 there. So that's client Y. You know, I'm just going to grab this and copy and paste it once for the left. So this is going to be the event.client X again. So let's grab that, event.client X, and this time if it's less than, Jesus, thank you Visual Studio Code, if it's less than the left, SVG left, okay, SVG left plus the gutter, so if it's over in the left but a little bit right, clear the interval, and then we want to do, we want to start moving our minus, minus step is going to be, and then we want 0 on the Y component. That should move us over left, and then the drag grid is going to be, the drag grid is going to be moving over to the left, so that's positive and 0. Is that right? Yeah, that should be right. Okay, and then we want one more. I hope this works, which is going to be the client Y. So this is going to be when we move. We've done the bottom, now let's do the top. So SVG top, and it's going to be minus the gutter. Oh no, sorry, we're going down. So the top, so if it's less than the top plus the gutter, okay, yeah. And then this time we want to say the X component is going to be 0, the Y component is going to be minus step, then this is going to be 0 for the grid, and then that should be the step. And let's also just change this 1000 to our interval time. Oop. And let's call that 1000. And let's do let's over there. Okay, fine. 1000, 1000, 1000. Okay, if by some miracle all of these works, I probably should have done one by one. But here we go. Let's try it. So let's move it over to the right. This was the one we did before. No, quite clearly broken that. What about the left? No. Top? No. Bottom? No. Okay, so what's going on there? Actually, it appears it is actually working. It's just very slow. I think I just put the interval on too slowly. So here we go. It is moving over. So I'll tell you what we should do is probably just change the interval time. So let's change that to 100. So we'll fire every 100 milliseconds. Maybe that'll be a little bit more realistic. So if we move it over, okay, fine, and let's do the other ones. Move over to the right, okay, so that's okay, and then move up to the top, fine, and then move down to the bottom. And looks like we need to put the stop propagation on some of these as well with it getting selected. Let's just make sure that that's set possibly. Okay. So that is kind of working. It is still scrolling until I think actually when we move away from the gutter, we need to cancel that as well. So let's just make sure that that is inside this block as well. So now when we move it over, good, that's better, okay. Okay, so we're still getting some selection there. So okay, I think I'm going to leave it there actually just for this one. There are still some other things that would probably be kind of nice to do on this. Like for example, maybe when you zoom, perhaps if you zoomed in at some point, you couldn't over zoom, so you couldn't zoom out any further than the bounds of your grid. For example, here we've got like a 2000 by 2000, so it would force it to the grid to align at the top left, so you would never end up with this kind of situation where you've got to kind of can't really see anything. Lots of little improvements. If there's anything you want to see, you think would be useful for this, just put something in the comments below, and you never know, may even do it. Okay, I hope this wasn't too painful and it was useful for somebody in some way, and happy coding. Cheers.